elements of a digital signal processing, then this digital signal processing, mainly it consists of three basic building blocks. Let us see why. Because this digital signal processing here, for digital signal processing, the input signal should be in discrete domain or digital, and the processed is also digital. But most of the signals which we encounter in nature are analog in nature. See, like the speech signal or sinusoid signal or any kind of a signal, say the noise or the chirping of birds or the sound which is coming from the flow of waterfall. We can use specific kind of embedded system to process that digital signal. But after processing, whether it's a filtering, amplification, or whatever the requirement, so once we get the output as a digital, so it may happen that we may not be able to interpret or understand very easily that digital signal. So again, there is a requirement to convert that processed digital signal into its corresponding analog part. So that's why again we use digital to analog converter. And then finally, here we end. So we say that digital signal processing mainly consists of three main blocks, or it mainly consists of three main parameters. And these are analog to digital converter, then a digital processor, followed by again digital to analog converter. And there are many advantages of this digital signal processing over analog signal processing. For example, certain advantages are listed in this slide. We can see here that the advantages associated with the digital signal processing is noise is easy to control after initial quantization. Then it's a highly linear within a dynamic range. Even the complex algorithms can fit into a single chip because it gives the flexibility of programming and reconfiguring the program. There is no need to change the component as in case of analog signal processing. And then it has a flexibility. Parameters can be easily varied in the codes. Then digital processing is insensitive. It is not immune to components like tolerances, aging, environmental conditions like temperature, pressure, and electromagnetic interferences. Whereas this analog signal processing, as we use resistors, inductors, so these passive elements have its parameter, it gets changed. When there is a change in temperature, definitely it will affect in the value of resistance. That's why we don't have the accurate output. So digital signal processing gives us very accurate output. And one of the advantages of digital signal processing over analog signal processing is it become now cost effective, because there is a huge development in the VLSI, and then mass production has led to make it cost effective. And moreover, like we need not change the whole components, but it gives us the flexibility to change some of the parameters in the software. That's why overall this digital signal processing becomes cost effective as compared to the analog. But still there are certain drawbacks with this digital signal processing. For example, discrete time processing artifacts like aliasing may occur. Then it requires significantly more power like battery and cooling. And then a digital clock and switching can cause interference in the circuitry. So and still, though there are many advantages of this digital signal processing over analog signal processing, but uh, there are certain areas where analog signal processing is used. For example, when we need to handle very high bandwidth signals, in that case we always prefer analog signal processing, because there is no need to convert that analog into digital, and again after processing, again it doesn't require additional circuit of digital to analog converter. So if we have a signal which has a higher bandwidth and we require the operation in the real time means output should be that moment only. In that case we need Still, we prefer analog signal processing. But because of many advantages of this DSP, digital signal processing finds in its application in the various domains. For example, in communication systems, then in astronomy, then in consumer electronics like perceptual coding of audio and video on DVDs, speech synthesis, speech recognitions, then in music also DSP applications are present, like audio effects, Dolby effects, these all. Then DSP has a huge role in the healthcare sector. So here, like in medical diagnostics, uh, digital signal processing finds its application in magnetic resonance, ultrasonic imaging, computer tomography, then ECG signal, EEG signal, and different kinds of medical signals. Then in geophysics, like oil exploration, then earthquake detection. Uh, in experimental physics, also for sensor-based evaluation. In aviation, like radar and radio navigation. Then in security, like steganography, digital watermarking, image processing, surveillance, signal interference, electronic warfare. So we find lots of application, but one most important application which drives us this signal processing towards machine learning is basically in engineering, where there is a work of feature extraction for pattern recognition. So with the help of this digital signal processing or signal processing, we can extract certain features, certain parameters from the signal, which are very relevant to and which carries information of that signal for the pattern recognition, and thereby moving towards machine learning. So hope this signal processing part is a bit clear to everyone. Mainly, we discussed in this section, in this signal processing section, we started our discussion with signals, system, then signal processing, then why there must be classification of these signals. Okay, and then we found the block diagram of a digital signal processing, some advantages of digital signal processing over analog signal processing, and then we found that this digital signal processing find its application in the various domains. Okay, and one important application of the signal processing is to extract information from the signal. And now we are moving towards machine learning. So before we start our discussion on machine learning, let us get ourselves familiar with certain terminologies which is frequently used in machine learning. Am I audible to you all?
Yes, sir, it is
Yes, sir.
audible.
Okay, okay. Thank you, thank you. Okay, so if you have any queries, you can stop me and we can have discussion. I hope that signal processing part is it's all right. Okay, so
Yes,
now
sir, this is
let us.
clear.
Okay, thank you, ma'am. And now let's move towards machine learning. So let us see what are the terminologies often we find in the machine learning. So one is artificial intelligence or AI. So basically, this artificial intelligence or AI, it approaches. Basically, it refers to approaches, techniques that enable computers to perform intelligent tasks. Okay, that intelligent task means some smart things should be there. That is called artificial intelligence. Then sometime we also come across pattern recognition, PR. So basically, pattern recognition, it refers to recognizing patterns in the given data. For example, sometime what happens that suppose if we just forget about our key. So what we do, we don't take the key from our pocket and we view the uh, we watch, or we don't watch, or we don't view exactly the same key, but just we put our hand on the pocket, and just by the pattern only we can recognize, okay, this is the key, or this is the pen, or this is this object. So the pattern recognition mainly, it refers to recognizing pattern in a given data. Okay, so there is a pattern for a fish, pattern for a key, okay, pattern from a pen, and then machine learning. So it's machine learning, basically it refers to approaches that learn the underlying pattern in given set of features without being explicitly programmed. So machine learning, like, these are the just terminologies. In detail we will be discussing in our next slides. So machine learning, basically, machine learning, it refers to techniques or approaches that learn the pattern, that learns the underlying pattern in the given set of features without being explicitly programmed. So there is no need to explicitly program, okay, but just it tries to learn the pattern with the help of features. Now question may be like, what do you mean by features? So if we have a signal, say if I consider, in the very layman's language, if I consider, say, apple, so this apple may have the features of its color. For example, it may be red, then its seed may be very small, then it may have a very less juice. So juice can also be one feature, its smell can also be a feature. So basically these features are defined as some of the parameters which defines about that signals. Okay, so this is about features. So some features may be very relevant, some features may have a very low information carrying informations. So basically when we talk of machine learning or ML, it refers to the techniques or approaches that learn the underlying pattern from a given set of features without being explicitly programmed. It is very important. And then the next higher level is the deep learning, DL. So deep learning, basically, it refers to the approaches, techniques that learn the underlying representation and patterns in given set of raw data without being explicitly programmed. So what difference we find in the machine learning and deep learning? We find that both the approaches mainly they try to learn the underlying pattern, but machine learning mainly it learns the underlying pattern with the help of some features without being explicitly programmed. Whereas deep learning, it tries to learn the underlying representation and patterns, the same thing, but in given set of raw data. It doesn't require features. Directly from the raw data, it tries to learn the underlying representation and pattern without being explicitly programmed. So in machine learning and deep learning, many things are common, but we find that deep learning, it learns the pattern from the given set of raw data, whereas in the machine learning, it is from the features. We need to extract feature for the machine learning, whereas in the deep learning, directly raw data can also be applied. So this difference we are finding. Then there is a relationship between the artificial intelligence, AI, pattern recognition, PR, machine learning, and deep learning. So we will find that this artificial intelligence is the superset, and it's more broader area. And then this pattern recognition, machine learning, and deep learning are like their subsets. And when we say artificial intelligence, so basically intelligence, it refers to experiencing or ability to learn and understand and use it for deciding future course. And like we have, like human have a intelligence. And then when we talk of artificial intelligence, means it's when intelligence by the machine, enabling our computers or machines to do so-called intelligent tasks. And these intelligent tasks may be to discover something, to learn, to deal with uncertainty and new situations, like our human intelligence does. And these artificial intelligence may be of two different categories, like symbolic manipulation is one form of AI, and one is connectionist approach is the another form of AI. So with the help of symbols, if it uses intelligence like coding and other things. And connectionist means like based on some clustering method, or with matching templates. So these kind of AI categories comes under connectionist approach. And then when we talk of pattern recognition, so task of modeling and recognizing patterns that are not directly obvious from the raw data or features. So with the help of a raw data or features, we try to get the some pattern which we find. So that pattern recognition is the task of pattern recognition. And like it also follows to, or it aims to mimic human way of dealing with external world through cognitive sensing and processing, because we know that this human mind has the perception and cognition sensing qualities. So this pattern recognition, this also tries to mimic human way of dealing with external world through cognitive sensing and processing. And then sensing, feature extraction, selection, model creation and comparison, able to demonstrate pattern recognition approach, template matching, stochastic or probabilistic modeling. These all are comes under the pattern recognition. But one of the drawback is that we have a limited computing power and data, and conceptually mimicked human way of dealing with the natural data is the main objective of this pattern recognition. And then when we come to, as we saw, artificial intelligence, pattern recognition, and now the machine learning. So with then the question is, why machine learning? What is the need of machine learning? Why we are not simply programming as we do in our uh, traditional codes? So machine learning, because this machine learning, it tries to learn the pattern with the help of some features obtained from the signal. And it becomes very difficult to write a program when we have lots and lots of data. That's why this machine learning has important role to play. So with more and more digital data available, so these days we the internet, and we see that there is a flood of data. So with more and more digital data available, task of automatic discovery and learning of patterns, both natural and synthetic data. So not much focus on the feature extraction, signal processing knowledge not prerequisite. So even if the signal processing knowledge is not uh, there, but still one can go for the machine learning. So because more emphasis is put on discovery and learning of patterns by the machine. Okay, so in the machine learning, the machine will try to discover, try to learn the patterns from the features, and ability to learn by extracting patterns from the data, that is known as features. And then these patterns can be treated as associated function to give the output. And then the higher level of this machine learning is known as deep learning. So there are certain drawbacks associated with the machine learning. Like if we have a like as we discussed, machine learning requires some features uh, in order to classify. Okay, but this deep learning, it directly can learn from the raw data. So task of learning both features and also patterns for pattern recognition. And this deep learning, it tries to mimic human way of learning from experience, need not specify everything in the beginning. It understand in terms of hierarchy of concepts, each concept defined in terms its relation and simpler concepts. And then there is a neural nets and deep learning. So the concept of deep learning first originated from the neural network. And this neural network, basically it's a part of a machine learning. And from machine learning, the advanced form of machine learning, or we can say that from machine learning, we moved forward towards the deep learning. So these neural networks, these are the special kinds of a machine learning technique. So now let us compare one kind of a machine learning, that is neural network, versus deep learning. So this concept of deep learning, it first originated from the neural network itself. And neural network, basically it's a machine learning. A good example of deep neural network is a feed forward neural network that is known as FFNN. And then back propagation is the workhouse algorithm for learning the parameters of FFNN. And then back propagation didn't work well for the networks having more than a small number of hidden layers. So generally we will find that this deep learning, it works well when we have a very huge data, and insufficient data, it leads to overfitting and difficulty in training of deep networks was the main limitation. So that's why for the deep learning, we must have the sufficient data. And then these slides mainly it says about how the how there was a evolution from the AI, artificial intelligence. So here we say that in 1946, ENIAC, it was the one of the world's first computer. And then in the 1950s to 1960s, there were the first artificial intelligence boom, and the age of reasoning prototype AI was developed here. And then in 80s to 90s, there was seen a second AI boom where the age of knowledge representation was done, system able to reproduce human decision making. So in that case, they tried to make robots. They have launched some cars also, like self-driven cars where there is no need of driver on pilot basis. And then in the year 2006, there were noticed a breakthrough in deep learning at the University of Toronto. And from 2010 onwards, we find third AI boom, which deals or which mainly spans the area of machine learning, followed by the deep learning. So now it is like it's a age of deep learning. And then let us see what exactly how these artificial intelligence, machine learning, and deep learning are related to each other. So we saw that artificial intelligence is a broader way of looking into, and artificial intelligence basically it is a technique which enables machine to mimic human behavior, whereas machine learning, it's a subset of AI. It's a subset of AI. We see that machine learning is a subset of artificial intelligence, and deep learning is a subset of machine learning. And so artificial intelligence, it refers to approach which enables machine to mimic human behavior, whereas machine learning is a subset of artificial intelligence which uses some statistical method to enable machine to improve with some experience. It uses some features, whereas deep learning is it is a further subset of machine learning which make the computation of multi-neural network feasible, and even if it can be applied to raw data. And then this is the history that how the growth has taken place, how like early artificial intelligence steers and how it has grown up with the different names. Like in the 1946 started, so say in early 1950s 1960, there was an era of artificial intelligence. And then from 1980s machine learning came into picture, and then further subset of this machine learning, or rather we can say that in this machine learning we have neural networks, and these neural networks has lead us to the deep learning where we have many hidden layers. And basically this deep learning after 2010 has lead to breakthrough to drive this third artificial intelligence boom. And this slide basically tells that for machine learning, if we have a input signal here, then there is a need of feature extraction. So features, maybe its color, it's some geometrical parameters, its intensity value, uh, any kind of features we can take from this input signal. So we need some feature extraction followed by say any classification method. This may be uh, supervised classification, unsupervised classification, or it may be a neural network. So any kind of a classification classifier we can use, and we can classify whether it's a cat or not, whether the signal is able to get classified or not. But in case of a deep learning, what we find that there is a no need of feature extraction. So basically, the advantage of this deep learning is that it eliminates the handcrafted need of feature extraction and feature selection. So it eliminates this need. So this is one of the very good advantage of deep learning, because extracting feature and feature selection, basically this is known as feature engineering, is itself a very tough task, and it's a challenging task. The reason is it becomes very difficult that when we have a signal, then which features we should take, which features are very relevant, and which features are able to exactly classify the object. That's why deep learning has an advantage that it eliminates the need for manual feature extraction and selection. So directly it learns features itself by the data, and it extract features, and it selects, and then it do the classification. So this is the main difference between the machine learning and deep learning. And then, like, machine learning may show the curse of dimensionality, or it may not be able to perform well when we have more and more data. But deep learning, if we have a lots of data, in that case deep learning performs well in comparison to machine learning. Then here the comparison of ML versus DL is given. So machine learning, actually, it gives good results with small data sets. Machine learning is quick to train a model. It doesn't take much time as compared to deep learning, where it's computationally intensive, and then we may go for additional like GPUs, graphical processing units. Okay, and deep learning performs well when we have a very large data sets. And in machine learning, there is a need to try different features and classify to achieve the best result. Whereas deep learning, there is no need for manual feature extraction and selection. Deep learning, it learns features and classifier by itself. And then in machine learning, we may have like accuracy plateaus, but in deep learning, accuracy is a bit unlimited. Then when we talk of machine learning, so this machine learning, it finds application in the various domain, but it is related to various fields. Like if we see this machine learning, so we find that various different fields comes under machine learning, because when we do machine learning, we must know about the data, about the statistics, about the information content in that data, what kind of database actually, then which models would be fit for this machine learning. And then this machine learning tries to mimic human behavior. So all the like physiological models, cognitive science, neuroscience, and decision theory, control theory, this all comes in picture. So basically this machine learning is primarily concerned, though machine learning is primarily concerned with the accuracy and effectiveness of the computer system, but it is related to various fields, okay, like data mining, statistics, and so on. So basically it's there are this figure says that different parts of other fields also comes under the machine learning. So we have talked about the intelligence, like it's a ability to learn, understand, and think, and according to the given situation. Then like we have also seen that what exactly the artificial intelligence is. So artificial intelligence basically is a branch of computer science dealing with the simulation of intelligent behavior in computers. And then the research and development on artificial intelligence, or AI, deals with the problem of making computers or artificial intelligence or actions similar to or better than humans. Okay, so the main aim is to mimic human human sense, and then like which task or which action it should perform. So like apart from standard mathematical problem solving, like artificial intelligence, machine learning, this can also used in various domains like detecting objects in a scene, then identifying silent objects in videos like a dog in a natural scene or a video, speech recognition, language processing, inferring or learning new skills, decision making, abstract thinking, emotion understanding, smell detection, and many such feelings and actions can be used using this artificial intelligence. And when we see the evolution of artificial intelligence, like we have previously saw that that from 1946, like how this artificial intelligence has gone to machine learning followed by the deep learning. But let us see what was the evolution of artificial intelligence. So basically the term artificial intelligence began to evolve when a small group of scholars from a variety of fields in 1940s and 50s started exploring the possibility of creating an artificial brain. So they wanted to create an artificial brain, and that led to the coin of this term artificial intelligence. Then cybernetics and early neural networks were proposed in 1940s and 50s. And then AI emerges, and then there was a Turing test by an eminent personality, Alan Turing, in 1950s. So in context to artificial intelligence, this Turing test, so in 1950, Alan Turing published a paper on the possibility of creating machines that can think. He noted that thinking is difficult to define and devised his famous Turing test, because it's not a physical quantity that thinking he will give some uh, parameters. He noted that thinking was very difficult to define. So he devised a test based on his name. That was the famous Turing test, to be called intelligent. So when a machine should be termed as as intelligent. So to be called intelligent, a machine must produce responses that are indistinguishable from those of a human. It means that if machine behaves like a human, if it also gives the same result as human will give, in that case we can say that this machine is a intelligent, it's a artificial intelligence. In other words, if a program or an artificial agent perform thinkings or acting like a human, thinking and acting rationally, it may be termed as artificially intelligent. An AI system, one of the characteristics of artificial intelligence system is that it must have an agent and the environment. An AI system consists of an agent and its environment. An agent is an object. It may be hardware or a software or a combination of both that can gather information about its environment and take decisions or action based on that information. Agents can be of several types like reflex agents, goal based, role based, or utility based and learning based. Then we know that learning basically it challenges with the environment. We may have a incomplete information or we may have a dynamic environment, and in that case, if if the machine learns from some experience, then we say that okay, this is the artificial intelligence, or from here actually, from this learning, this the concept of machine learning emerges. So when we ask a question like what is learning, so as per a cognitive psychologist Herbert Alexander Simon, learning denotes changes in the system that are adaptive in sense that they enable the system to do the task drawn from the same population more efficiently and more effectively the next time. Okay, so this is the meaning of learning. For example, if we show a small cow to a child, and then after some time he sees a very big cow, then also he will be able to know that okay, this is the cow. So basically this learning, it denotes changes in the system that are adaptive, or even if some part of that cow is shown, then he can be able to say that okay, this is the cow. And again, as we have already discussed, but in more deeper sense, like uh, in context to machine learning, it's very hard to write programs that solve problem like recognizing a face. So question comes that what is machine learning, or why there is a need for machine learning, why we are not writing our conventional codes or the program. So answer is that machine learning, because there is a need of machine learning, because it is very hard to write a programs, to write a code that solve problems like recognizing a face, or when we have the data, huge data, or when we have always flow of flood of data. We don't know what program to write because we don't know our how brain works. Even if we have a good idea about how to do it, the program might be awfully complicated. So because it will be really very complicated, so instead of writing a program by hand, we collect lots of examples that specify the correct output for a given input. A machine learning algorithm then takes these examples and produces a program that does a job. The program produced by learning algorithm may look very different from a typical handwritten program. It may contain million of numbers. If we do it right, the program works for new cases as well as the ones we trained it on. So actually, the question is here. Actually, these slides mainly tells the importance of machine learning. It answers why there is a need of machine learning. So once again, because we know that like if we have a lot of data, or sometimes like it becomes very difficult to write the programs that can solve some recognition or pattern forming problem. Say suppose we want to authenticate a person with the help of some face. So in that case it becomes very difficult, because the aim of this machine learning is to mimicry our human brain. And how our human brain works, it's very difficult to write that in the program, but our brain mainly based on the pattern. So that's why what we do, instead of writing a program by hand, in machine learning we collect lots of examples that specify the correct output for a given input. So suppose in case of a face recognition, so it will take lots of faces of people, different people, and then based on that different faces, it will prepare a database, and it will train the machine learning algorithms uh, to form a pattern and to know about that face. And then if during the testing, if a new face will be given, so if its characteristics matches with that of the database, then it will tell that okay, this matches. And if it doesn't matches, then it will say no, this is not the authenticated person. So that's why this machine learning algorithm, it takes lot examples and it learns, and there is no need to write the program. The program produced by the learning algorithm may look very different from a typical handwritten program, and it may contains million of numbers. If we do it right, the program works for new cases as well as the ones we trained it on. So even a new images is given which is not in the database, then also it will be able to tell whether it is the correct person or it is not. It should not be authenticated. Then we discussed this, that machine learning is concerned with the computer programs that automatically improve their performance through the experience. So as per the number of iterations and previous defined parameters, so it is concerned with the computer program that automatically improves their performance through the experience. But if you write simple code, it may not be able to improve. It will give the same output. But in case of a machine learning, it is designed in such a way that it is made in such a way that it is concerned with the computer programs that automatically improve their performance through experience. Then why machine learning is required? So we already discussed that because when we have a flood of available data, especially with the advent of internet, we have lot of data. And Google, we know that Google or search engines has to use lot of data. Okay, so and then in the because of advancements in VLSIs, we have an increasing computational power of machines. There is a growing progress in available algorithms and theory developed by the researcher. There is a increasing support from the industries. That's why this machine learning has found huge popularity, and like we have everywhere machine learning, artificial intelligence, deep neural networks, deep learning, all these things. So sometime like when we search something on the Google, and the next they learn our behavior, and then they will show the same thing to us. So this is also one example of the machine learning. Then these slides, it mainly tells the difference between our traditional programming and machine learning. So like here in the traditional programming, we have a data and we have a program. This computer will process and it will give a output. But in machine learning, like we give data, we give certain signal as the output, and then uh, based on that learning, it makes a program. And then the three most important components of machine learning are data. From that data, it extracts relevant parameters which can define that data. So these are known as features. So maybe high level features, low level features. Okay, and then it uses some of the algorithms, like whether supervised learning algorithm or unsupervised, or reinforced machine learning algorithm, or neural networks algorithm. Maybe different types of algorithms we have, classifiers we have. So mainly there are three components of the machine learning. One is data. Then from data we get features, and then when we extract these features, we apply some of the suitable algorithms. So the three components of machine learning are data, features, and algorithms. And we also find that this machine learning, basically it's a intersection point for data mining, data science, and classical programming. So machine learning requires the knowledge of data science, where we have to study stochastic or statistics, probability, all these things, then data mining techniques, and then programming too. Then like here, it is here like machine learning. Now we know that it's a field of computer science that gives computers the ability to automatically learn without being explicitly programmed. There is no need to program. It learns from the experience. So learning from experience on data to make the prediction. So here, like we have, it's very important. Let us see here. This is a database. So first is training, and then so here we have a lots of data here. So based on this data, machine learning algorithm will learn. Suppose if we have different data here, say different faces of different people in the database. So it will learn, it will make some uh, like features, and then it will try to learn. And then when we want to test it, so based on this machine learning algorithm, it will train the model that if these features comes, you have to tell that this is the kind of data. Okay, so we have a data here. It is a training data set. With the help of some machine learning algorithm, we will be discussing soon about machine learning algorithms. So here maybe like supervised machine learning algorithm or unsupervised. Okay, so here we have a algorithm, and then based on this algorithm, we will model. So a trained model will be here. So this has the this has learned from the data. That's if this characteristics comes, then we have to put that in this category. Then we will give an unseen data to test whether our trained model works correctly or not. So if we give a data here, so it will again match certain characteristics which he has learned. So if it matches with that, it will say that this comes under that category. So this is the working style or working principle of a machine learning. In more detailed way, like I can say that suppose in this data, in the training, say we have a two kind of data. Say here in this data we have a two sets of a data. Say for more simplicity we are talking of a biomedical signals. Say one is a diseased data and another is uh, normal data. So say we have a here heart sound signals, abnormal heart sound signals which shows some of the cardiac abnormalities, and we have a normal data which refers to data of a healthy person. So now here we have a two kind of data. So now with the help of this machine learning algorithm, it will learn and it will make here two separate features, or two models it will develop, that if these characteristics are there, it will tell that these are the abnormal signals, means person is suffering from cardiac abnormalities, and if certain other characteristics are there, then it will say it's a normal data. Now say unseen data we provide here. Say we have given some abnormal signal. So these abnormal signal will be compared with the normal as well as abnormal models. Then definitely if it is trained well, if the algorithm is right, it will match with the abnormal, then it will say that it is a abnormal. So in this case, so this is the way that how the machine learning works. So that's why there is a call. So when we talk of machine learning, there is a training and testing phases. There is a training and testing phases. So first, like we have a training set here, training set. So here, say we have a two training set. Say this is normal and this is abnormal. So it takes samples from the data. So we have a universal set of data which is unobserved. So training is a process of making the system able to learn. So in the training, with the help of ML algorithm training, it observes the data and it learns from the experience and it makes its own model. And then for the testing, we give some real world problem or some data, and then it will, from the experience, from that model, it will try to tell from the same universal data set. If we give the input, it tries to classify. And most important part of machine learning is that it is able to learn and extract patterns from the data. And a computer program is said to learn from three things: ETP, that is experience, E with respect to some class of task, T, and performance measure. If its performance at task in T as measured by P improves experience, E, then we say that machine learning algorithm is fine. Then this machine learning can be of two kinds broadly: supervised learning and unsupervised learning. So as the word supervised, so supervised learning of machine learning refers to, like, there is a supervision, like whatever, when we train the model, when we train the machine learning algorithm, in that case we label the data. Like if it is a abnormal, then we will say that it will label it, that okay, these are, or say we want to classify mango and apple, then all the mangoes will be labeled as mango and all the apples will be labeled as apple. So in case of a supervised things, when we train the signal, this signal may be some documents, image, sounds, or any kind of a signal. So that signals are labeled For example, if it's a binary class problem, then say abnormal images. So say it will be labeled as 1, and normal images it will be labeled as 0. So 0 will signify that okay, this is one class, and one level 1 will refer to some other class. So in supervised learning, the training signals or the training input signals are labeled already. It is told prior to the learning, and then based on that labels, it learns. Okay, it learns, it makes some features, and then represent it in terms of feature vector, and then predictive model will tell about the label. Okay, about the label. So when unknown signal will be given, so it will match with that of the experience of the machine learning algorithm, and it will tell the expected level. So if it is 1 or if it is 0, so accordingly it will tell that it was abnormal or normal. So actually, just in a very nutshell, supervised machine learning are those kind of learning where input signals are labeled, whereas like unsupervised learning refers to the signals or algorithms of machine learning where input signals like our training texts or documents or images or sounds, they are not labeled. So we are not going to label those signals, say abnormal signals as 0 or normal signals as 1. We are not label, we will directly give all those. So whether it's two kind of signal or three kind, we will directly give to the algorithm. So in that case, it will automatically, it will learn, and it will extract features, and there will be no labeling. Okay, so this is the unsupervised learning. So let us see what are the different algorithms that comes under unsupervised learning and what comes under supervised learning. So like some popular learning algorithms which are frequently used are uh, in under unsupervised learning, when we don't give any label to that. So all those signals will make some clustering part. So like K means clustering, principal component analysis, PCA, then generative models of neural networks. These all are termed as unsupervised learning because we are not going to give the label to the input signals. So in case of a K means clustering, which we will be discussing very soon. So in K mean clustering, like we are not going to label the input signals. So say we have a two kind of signal. So directly two kind of signals will be given to the algorithm, to the machine learning algorithm, which is say K mean clustering. So this K mean clustering will make clusters. So finally, after iterations, finally it will make the two different classes based on some parameter, like say Euclidean distance or some other parameter. So it will make the two clusters. So say if we have a two class, mango and apple, so all the mangoes will be clustered in one group and all the apples will be clustered in one group. But prior to clustering, we have not labeled that okay, if this is a mango it is one, and if it is a mm, if it is an apple it is 0. We have not labeled. So unsupervised learning are those machine learning algorithms where inputs, say image or some document, these are not labeled, and they just with the experience they learn from it and they make some groups. So under unsupervised learning we have a k-mean clustering, principal component analysis method, generative models of neural networks. Whereas in the supervised learning we saw that we give the labels to the input signals before training them. So like support vector machine, SVM, it's very famous, neural network classifiers, decision tree, this all comes under supervised learning. And then we have a reinforced learning also where we give some reward. Okay, so those things we will be discussing later. So this is like I have taken this k-mean clustering uh, one example of unsupervised learning in detail. So actually this k means, so we can put the value of k as 2 3. Okay, it is basically it's a program specified, we can put manually the value of this k. So this k means is a partitional clustering algorithm, also known as Lloyd or Lloyd-Forge algorithm. The k-means algorithm partitions the given data objects into k clusters. So if we have a two class of data, say abnormal and normal, then we have to put the value of k equals to 2. So it will classify whole data into two groups, two clusters. Each cluster has a cluster center called centroid or prototype. The number k is selected either through a guess or using some prior information about the data. Then this is the k-mean clustering. So here what we find that here two class problem is there. So say first it chooses this. So here k equals to 2. Here we have chosen 2. So k is 2 here. So those signals which have similar properties, say in terms of say Euclidean distance or any parameter, so it will cluster together, and then at the end we will find that there are two groups. So this is one example of k-mean clustering. So here actually these three different centroids or prototype has been obtained in this figure. So all the similar pattern of data will be put together. This is, say this is mango, this is orange, and uh, this is say apple. So this will make some group because they will share the same characteristics within its one group. Then how mathematically it works? So basically, say we have a given data set x1 x2 till xm, then we randomly select k data points as initial centers, and their centroid are say mu1 mu2 mu k. Then we put say r equals to 1, and then we will repeat 1 to 4 until there is no change in the center assignment. So if there is no change means all have came to their respective groups. So for each center, find out the distance between each object and the center. So if we have a center, or it's very analogous, say in a room, say there are 50 people. So after some time we will find that they will make some groups. So based on certain common characteristics, they make some groups. So here in k-means algorithm, we also do the similar kind of thing. We assign each object the cluster having least distance from its center, and we try to minimize the Euclidean distance. And finally, with this iteration process, we find that at the end, when there is no change in the assigned center, then we stop. And at the end, we find that the cluster has formed. Okay, cluster has formed. So mainly this k-mean clustering algorithm, the objective function strives to minimize the sum of squared error distance or scatter. Then only it guarantees that there is a clusters, and it doesn't guarantee to reach the global minima. And the features of k-means is that it's very easy to understand and implement. Okay, it takes the, but and it's not very complex also. Okay, it's linear algorithm. Okay, so k-means is a very simple, but weakness is that one need to have a good guess of the number of k, because when we have a initial data and it's a unsupervised learning, so we don't have a label that if we have a three different levels, then there are three classes, we can put k equals to 3. But as it is, k means a clustering algorithm is a unsupervised machine learning, so we never know the exact value of k, so we have to guess the value of k. The algorithm is only applicable if the mean is defined, because first we have to define the mean, and it has a drawback that it is sensitive to some other data. If there is a noise, it may not perform well. Okay, then the then then after certain, then a breakthrough came when support vector machine SVM which is a supervised machine learning algorithm used in the, actually that was which we discussed, that was unsupervised, but this SVM is a supervised. It was developed by Wapnick and his team in the Bell Lab in between 1992 to 97. So support vector machine is a very popular machine learning classifier used for data classification. So the idea of support vector is that basically suppose there are two classes in a data set and the data are linearly separable. So if the data is linearly separable, uh, we can find a straight line that separate these two different categories of data. Now we must select this separating line such that there is a huge margin between two. Then only we will say that it's a because if there is a, if if I consider these many lines are here, so the best classifier or the best line which separate these two should have the maximum margin from the two, so that even some noise or some other also comes, then one object of one group should not go to the second one. So which line will be the best? So the line which separates or which maximizes the margin between two classes will be considered as a best separator. Okay, so in order to like how to find out the line that maximizes the margin. Okay, so if I consider this this one, if you see this one, so definitely this line is not good because it is very close to this group. But this one, this black one is the best because it gives the good margin to both the classes. So how to mathematically do that? So there is a well developed mathematics here. So mainly like we have to define decision boundary, the line that maximizes the margin between the two classes. Then support vectors, basically those vectors that are at minimum distance from decision boundary are known as support vectors. Then we have a supporting lines, okay, lines parallel to the decision boundary line that has the support vectors. Then we write the equation and we follow some optimization problem. So we are not going much in detail, but it's a well developed, and we try to maximize the margin. uh, we use optimization technique, and then so problem formulation, these all. And sometimes like if there is a linear, then it's fine, but sometimes we may go for a non-linear boundary. In that case there is a concept of kernel. So this kernel in the SVM, it creates non-linear classifier by applying the kernel trick. So it maps the data to a sufficiently higher dimension where it easy to classify using a linear decision boundary. Like in control engineering also, like we have a like non-linear system, then we try to do something, some trick or some algorithm we apply so that it becomes linear for particular parameters. So same here also is done. Like when we have a non-classifiers, when the decision boundary is not very linear, in that case we play kernel trick, and with the help of different kernel sizes, different kernels, we map the data to a sufficiently higher dimension where it is easy to classify using a linear decision boundary. So this is the example of a kernel. Like if we have an input space, and here we cannot use direct one straight line, it cannot be able to classify, the straight line cannot, so we must use a non-linear so that two different classes will be classified. So for that we use kernel so that it will be mapped to higher dimension of plane, and then classification can be possible. And then the last one, within 5 minutes I will cover this. And the another uh, important algorithm of machine learning is artificial neural network. So actually where how the motivation comes for ANN. So building an artificial brain or challenges, computing power versus cognitive sensing. So computer has lots of computing power, but our brain has a cognitive sensing. So this artificial neural networks tries to to mimicry our cognitive and perceptional qualities of the brain with the computing power of the machine. So there is a contrast between this uh, machine and our brain. Like if we talk of arithmetic, so our brain is definitely, it's 1/10 of simple calculator if we compare with the machine. But if we see the vision, one brain outperforms hundreds of parallel high-speed computers. Memory of arbitrary details, if we consider, then computer outperforms. But memory of real-world facts, then brain wins. A computer must be programmed explicitly for the different tasks. Brain can learn from experiencing the world. Brain has inherent advantages like parallel processing, fault tolerance, graceful degradation, and ability to generalize. And these qualities machine wants to mimicry. And for that, it's important that how our brain works. So as the very basic level of brain is composed of neurons, so they try to model the neurons with the help of artificial neural network. In information processing paradigm inspired by human brain's information processing mechanism. So basically this artificial neural networks is composed of a large number of highly interconnected processing elements called neurons working in a unison to solve a specific problem. So these artificial neural networks learns by examples like human being. So this is the mathematical model of a neuron. Like we have different inputs and weight, and then it is summed. We give some activation function and it gives the output, like our brain. But now, as we are at the end of almost end of this session, so now we discussed about like machine learning systems, but there are certain limitations which ML system suffers from. So one is curse of dimensionality. Many machine learning problems become exceedingly difficult when the number of dimension in data is high. So this is known as Hughes or parking phenomenon. So if we have a high dimensional data, in that case machine learning's performance is not good. In that case deep neural networks is good. And this curse of dimensionality, with a fixed number of training samples, the predictive power of a classifier or regressor first increases. As the number of dimension or features is increased, then the performance goes down. So example of machine learning problems with high dimensional data are speech recognition, object detection in images. That's why in these applications, deep neural networks outperforms machine learning. And limitations of ML systems also, that traditional machine learning uses manually designed features, and manually selecting features and extracting features and selecting features is a very difficult task, often over specified and incomplete, mostly application dependent, cannot be generalized easily to other application, and it's time consuming in design and validation. Developing handcrafted features is costly and complex also. So machine learning has a problem of handcrafted feature extraction and selection. So how to overcome these limitations which is present in machine learning? So the solution is deep learning, and this deep learning has emerged as a very powerful tool which doesn't need the manually handcrafted feature extraction and selection. It eliminates the complete stage of feature extraction and feature selection. It does automatically from the raw data. And deep learning outperforms when we have a floods of data or high data. That's why deep learning has taken the place these days. So with this, I would like to thank you for the patience hearing, and just let me within 2 minutes, let me just revise what we have discussed in this session. So mainly we started our discussion with the signal processing followed by the machine learning. So in the signal processing, we started with the signal. That signal are basically these are the physical quantities which varies with respect to some of the independent parameters, like sinusoid signal or speech signal or biomedical signals, like our cardiac signals, electroencephalogram signal, electrocardiogram signal, speech signal. And these signals carry some information. It carries some vital information from where it has been originated. So it carries the information of the system. So these signal and systems are very much connected. These are indispensable. These are indispensable. And when we define system, though there are many ways to define the system, but in context to signal processing, we say that these systems are mainly a physical device, or it may be a software or a combination of both, which performs on the signal to give a desired output. So that is a system. A filter can also be considered as a system. An amplifier can be considered as a system. And these signal and systems are indispensable. They are the two sides of the same coin. For example, if we have a cosmic wave, or if we have a seismic wave, earthquake, so we have from the earthquake signal, from the seismic waves, from the earthquake signal, we can tell about the information about from where it has originated, what was the intensity of earthquake. And then signal system, and then we reach to signal processing, which is the method of extracting information from the signal. And when we do this in the analog domain, then it becomes a analog signal processing. And when we do this signal processing, extraction of information from signal by some digital means, then it becomes a digital signal processing. There are advantages of digital signal processing, and this digital signal processing finds application in the various domains. One example was extracting information from the signal, extracting features from the signal. And this feature engineering has led us to machine learning. And before machine learning, artificial intelligence came. So one subset of this artificial intelligence is machine learning. And one further subset of this machine learning is deep learning. And when we see the evolution, artificial intelligence, then comes the machine learning, and after that deep learning from 2010 onwards. And then in machine learning, like we have a supervised learning, unsupervised learning. There are certain advantages of machine learning which our human brain do not do, but it tries to mimicry our brain. Okay. Then like then when we talk of like it tries to mimicry it tries to mimicry our human brain, uh, but it has certain advantage. But again, we found that it has a certain disadvantages, like curse of dimensionality. It doesn't work well when we have a flood of data. Then the solution is deep learning. Okay, so as time couldn't allow me to go for some MATLAB programming, so maybe in the next session when we will be meeting in future, we will be discussing on some more aspects of machine learning. So with this, I would like to conclude, and thanks, and I welcome if you have some queries. Thank you. So if you have any queries, you're welcome.
Good afternoon, sir. This is Nandini from Congo Engineering College.
Yeah, good afternoon,
Uh,
ma'am.
Sir, I would like to know what all the features are available in signal. For example, we take it as an encephalography signal. I saw a number of data set available in the EDF format.
Hmm.
How can I fetch the feature from that data set, sir? What are all the features available in that signals?
Okay, okay. So actually, like as we discussed in this session, that like feature extraction and feature selection itself, it's a very challenging task. So we have to choose very relevant features. So suppose if we have first, and this feature, it depends on the data, that which kind of data we have. For example, if we have, say, if we have, say, some biomedical signals, as you told, so in that case, we have to know about its time, time based features, its frequency based features, then time frequency, both time frequency based features. So you may go for, uh, in terms of its amplitude, in terms of frequency. So frequency may be one feature. Then you may apply some signal processing tools like wavelet transform. In that case, their wavelet coefficients may be one of the features. So we have to see that which features will be relevant to classify, or in order to recognize that kind of a signal. For example, if when we talk of speech recognition, in that case, like most of the features are based on male frequency spectrum features. Okay, so it's a very difficult task. So sometimes people prefer some kurtosis and skewness based features. Okay, because it tells about, it captures the geometric pattern of the signal. So actually, based on the literature and based on the type of data, we should extract the features, and then we should feed to a classifier. And in order to overcome this problem of feature extraction and selection, these days directly people are using deep neural networks like convolutional neural networks, which do not require the features. Directly we have to give a raw data, and it will learn itself, it will extract features, it will select some relevant features, and then it will give to a classifier. Hope, is it clear, Nandini
Yes, sir.
ma'am?
Yeah, thank you, sir. Because these features are statistical related features. Yes, sir.
Yeah, statistical features, yeah, but it's like, suppose in the literature review already some of have done the statistical features, then it's better to search some other features, like based on some timing, or based on frequency, or convert that signal to another domain in the frequency, then try to get certain different features. Okay,
Okay.
so then we have to compare that with this feature or combination of different features, which one is giving better result. So that will be a different kind of work related to machine learning.
Thank you, sir.
Welcome. Yeah, so I have shared these slides to Professor Midhili ma'am. So if there is no any queries, then I would like to extend once again uh, thanks to the organizer, and especially Professor Midhili ma'am, who have given this opportunity to share my expertise with all of you. And thanks to my dear participants for your valuable time and for your patient hearing. So thank you very much.